we are going to be considering what? Chemistry practical, alternative to what? Chemistry, alternative to what? Practical, alternative to practical, Now, and the is actually on quantitative or volumetric analysis. I just want you to know the hiding volumetric analysis so that you'll be able to what? Relate. Now, here is the question under it. A is a solution. A is a solution containing 6.0 gram of impure sodium triisocarbonate 4 salt, definitely salt, or it can be weak base. So in 1.0 dm cube. Now they give you A to be what? To be A contains what? 6.0 gram of impure sodium triisocarbonate what? 4 in 1 dm cube. In 1 dm cube. Now, what does this one suggest? Because every information you need to interpret for you to actually what? Get these questions. So 6.0 gram of impure, meaning that the mass of the substance weight, which is sodium triisocarbonate 4, is actually impure. It contains, maybe it has mixture of other salts inside, but they tell us it's an impure salt. It is not totally what? Sodium triisocarbonate 4. So you have to know that. And that what? And that weight of the salt measured is about 6.0 gram, and it was dissolved in 1.0 dm cube. That is, it was dissolved in 1000 centimeter cube of water, distilled water. So meaning that they are giving you some information here that you need to what? Actually denoted from the what? From this statement. Now, what does that mean? This is the mass concentration of the solution obtained when the salt was dissolved in water. Now, when you dissolve salt in water, it forms solution, and they are trying to give you that mass concentration of that solution. So meaning that the mass concentration of A will be what? Mass all over the volume. So meaning that we have 6.0 gram all over 1.0 dm cube. So which is equal to 6.00 gram per dm cube. This is mass concentration. You have to know that first. Now let me check my video whether it's still on. Yeah, we are still there. Now that's the first information. I just quickly draw this one out and draw your attention to it as we move on, because this is not the first question, but you must be able to actually denote the information from this statement. So now, they now told us that B is 0.1 mole per dm cube HCl, hydrochloric acid. Now B is 0.00 mole per dm cube. Now of HCl. You can see that here they give us mass concentration, here they give us molar concentration. There are two types of concentration of a solution. You see that they express it in gram per dm cube, or they express it in mole per dm cube. The gram per dm cube is what we know as mass concentration, while the molar concentration is what we know as mole per dm cube. So this one is molar concentration, while the mass concentration of this one is given. So can you see the difference? So now moving forward, now they now say titration of 25 centimeter portion of A. Now they carry out titration analysis of A. Titration of 25 centimeter cube of A. That is, they measure 25 centimeter cube of A solution and they titrate it with B using methyl orange. I've done series of practicals on volumetric analysis. If you don't know how this is done in a real life, try to go through my videos. There are a lot of practical that I've done on volumetric analysis where I actually use sodium, especially sodium triisocarbonate 4 and HCl. But for those people that are watching this video for the first time, I can just quickly run it through. Just what we are going to do is that you pipette this with what? When you are doing the practical, you pipette the solution sodium triazocarbonate 4 with 25 cm keyboard pipette. You suck it, or in a standard lab, you don't suck it. You use your what? You use your suction pump, or you use what? Pipetter to pipette the what? The 25 cm cube of what? Of A, and put it in a conical flask. Just like, let me just sketch it for us, just a brief sketch. So you pipette with your this what our pipettes look like. So you pipette from a bottle, or let's say from a beaker. You pipette from a beaker, then you transfer towards you transfer this with a pipette. You transfer with a pipette now inside this. Then after you pipette, you add your indicator. You have pipette you pipette using this one, you have pipette, then you add your indicator. Just 2 drops of indicator into this, then 2 drops of indicator. Then after you do, this is step 1, pipette. 2 is add your indicator, this indicator, and then the step 3 is to what? Introduce your what? Acid from the what? Retor stand. From the retor stand. So from the retor stand, let me just say this is, assume this is your retor stand. Don't forget this is just a sketch, so don't expect perfection. So everything is carried out on a what? So this is your retor stand holding it. So this is your acid, this is where your acid is ACl. This is where your what? So this is what it happens there. This is how the practical is being carried out. So now you take your what? Base, you put it inside your conical flask. That's the first step. Then you add your indicator. Then the third one is now running out this. So this is 1, 2, 3 steps. So it was carried out. This was carried out using methyl orange. This is the methyl orange, and then this table was obtained after they carry out this whole experiment. They carry out this experiment, then this result was obtained. That's why they said after the titration of 25 cm cube of portion A with B using methyl orange as an indicator gives the following result. Now this is the result. Now they now say complete the table, complete the table. So we have to use this result to answer the following question. So that's why it is alternative to practical, because the result has been given to us. You don't need to do the real practical. They have already did the practical, and they have gotten some volumes, and they present it in a table, and then you have to use that table to answer the questions asked. So now, so that's just the brief explanation of the practical. So let me just clean this, and then we move forward. We have the table. Now let's go back to the table now. What are we expected to do from this table? Now we have Burette reading here, which is final Burette. You can see Burette reading in centimeter cube. Then final reading, initial reading, volume of what? B used. So now, what we are going to do is that we are going to subtract this from this. So we are going to have what? You are subtract the initial from the final. So we have 24.80 for this. This one has already been subtracted. So we are going to subtract this from this to get the missing part, because we are asked to complete the table. So now let me just bring my calculator to save our time. So we have 36.80 minus 24.30. So we have 12 point what? Have 12.50. Yeah, 12.50. So that's the start, the initial from 12.50 here. So now, and the next one is 43.40 minus 18.80. So we have this one to be 24.60. Now Look at this very well. We have already completed the table. That's the first question under the particular questions. We have the what? We have the completion of the table now done. Then calculate the average volume of B. Now, average volume of B now is the second question. Average volume of B. And how do we go about that? That is the second question we have to go to. Now, when you are doing this kind of calculation for average volume of B or A, whatever you are doing, whatever you are looking for, average volume, whenever you are asked to calculate average volume in this kind of question, you are to use two concordant values. Please, I need to repeat this very well. Two concordant values. You are expected to use two concordant values. Values that are not having differences of more than what? They are not having differences of not more than. They are not have difference of not more than. I repeat myself again. Not more than 0.2. Their difference should be not. Their differences must be between 0.1 to 0.20. Sorry, yeah, 0.20. Their difference should not be more than 0.20. And do you get now? 0.20. The difference is not much more than this. Look at what I'm trying to say is this. Look at this one. The difference between 24.30 and 24.80 is 0.5. There's a huge difference here. Why the difference between here and here is 0.3? But the difference we are looking for must not be more than 0.2. Please note that. So, meaning that this and this cannot be used, this and this cannot be used for average value because they have the difference of 0.5. This one and this one has difference of 0.3. So this and this cannot be used. But when you compare the first and the third, 0.2 is the difference, because when you subtract this from this, you are going to have exactly 0.2. So meaning that these two, this 1 and 3, that is the first volume here and the third volume here, are concordant because the difference is just 0.2. So we refer those values where the differences is not much as concordant values. So we are going to be using what? The volume 1 plus volume 3. So because these are the concordant value divided by 2, because we are using what? We are using that 2 volumes. So from here now, I'm going to be saying, okay, since I have volume 1 and volume 3 now, so we have 24.80 plus what? Plus 24.60 divided by 2. So let me just separate it to brackets so that I can see the very well. So when you add this one together, I think I'm going to get to 24.70, but let me just do it to confirm with 24.6 divided by, okay, divided by 2. So I say 12.70 centimeter cube. Don't forget the unit is very, very essential because it's in centimeter cube. So that's that. So I hope you remember why we use these 2 volumes, because they are concordant. So now we have done, this has been done, and this has been what? So let's move to the next question. They said the equation of the reaction is very, very important. We have been given an equation of reaction that you need to take note here. And the most important thing about the equation of reaction here is the mole ratio. That's the most important thing. And in most cases, they will have balanced the equation for you. In most cases. But if they didn't balance the equation for you, please balance it for yourself. But in most cases, in most questions, it is always balanced. And the most important thing is that the mole ratio of this one to this one is 1 to 2. Ratio 1 to 2. That's the major important thing in this equation of the reaction. So this is the equation of the reaction here. Trying to let you see the equation of reaction very clearly. So that's that about that. So note that. So the answer from the information provided and the calculation you have made, calculate the concentration in mole per dm cube of sodium triiosocarbonate 4 in A. Calculate in mole per dm cube the concentration of the sodium triiosocarbonate 4 in A. Now, I told you that initially, what we have here is an impure. Don't forget, the mass concentration that we have here is a mass conc that we have here, which is gram per dm cube, is a mass conc of an impure what? Of an impure sodium triiosocarbonate what? 4. It's not pure. But here we are asked to calculate concentration of the mole per dm cube of concentration in mole per dm cube of this in A. Meaning that what you are trying to say is that we are looking for the actual concentration of pure sodium triiosocarbonate what? 4, not the impure now. So to get this, there is a place to apply some wisdom here. So now let me clean this so that we can follow the calculation. So since we have done this, let's just don't forget we have been given 0.01 dmk. Let me quickly write down because it's very, very essential. We have been given okay, I've written it out here. 0.10 dm cube of what is here. I've written it out. So the formation I've written out before I actually wipe this one off. So here we have this and this. This. So now, this is the equation of the reaction, and we are asked to calculate the concentration of sodium triiosocarbonate 4 in mole per dm cube. That's what we're asked to calculate this. That is the pure aspect. Now, the first thing you are going to do now is to use what we called, now the popular formula that we know is, let me write it here. The popular formula that we know is using, I'm trying to solve this one now, using CA VA over CB VB equal to NA over NB. Usually this A is usually used for acid. Please note that. Usually this A is usually used for acid in the normal sense, but they have changed it to this acid being the B now, and then the base being the A. Please note that they have changed in such a way that what? The acid being the what? The acid is always being the A, and then the base always being the B. But in this case, they have changed it. So you can as well change your own as well and put the what? You just turn it over, change it to be what? Since acid always be in the front, we have CB, VB. Acid supposed to be on the top, right? Over CA, VA over NB over NA. So I just turn it over because our acid here is what? Is B. So we now have, so I'm going to use that expression here. So I'm going to be using what? CB VB over what? CA VA equal to NB over NA, because many of you are used to this one. So now let's substitute now. What's the concentration of CB? It has been given directly from the question, so don't bother yourself. Just say 0.10 times Now VB is what we get here. This is your VB here. What you get here is going to represent your VB, average volume. So we have 24.40. Now, very, very important. Let me write it such a way that we have much space. So we have 0.10 times 24.47 divided by CA. That's what I'm looking for. Don't forget what I'm looking for here. Concentration of sodium in what? Mole per dm cube is same thing as, instead of writing, let me just write CA here. It's same thing as my CA, which is unknown. So CA multiplied by VA, 25. Don't forget, they say 25 centimeter cube of A. So 25 centimeter cube of A. So that's the volume of A. So equal to NA. Look at this, come to this place. This is your NA. This is, don't forget, this is your A and this is your B. So what is your NB here? Is the one here. This is your A, this is your B. Your N, if this is your A and this is your B, your NB will be this one. This is your NB and this is your what? NA. So don't mix it up. So my NB here is 2 because the number of mole here is 2, and then this one is 1. So with this now, we can now cross multiply. So I have, if you multiply CA times 25 times 2, that is cross multiply. We are going to have 50 CA equal to 0.10 times 24.70. So divide both by 50. 50. So what do you have for your concentration of A? We have 0.10 times 24.70 divided by 50. Format decimal. So this is 0.0494 mole per dm cube. So that's that about this question, Roman figure B, Roman figure 1. Let me check my. So that's that. I've successfully calculated what this one. So I've calculated this now. So which one should I clean? Which one should I clean? Okay, since I've used this one, I think I should go with cleaning of this. I will still use this information. I think I'm probably through with this. So let me just clean it up. Just follow. I've done this one, so I can clean this. So the next question is mass of sodium tricarbonate 4 in 1 dm cube of solution. Now I told you that what you just get here is the pure concentration. The pure concentration of what? A. Of A. The pure concentration of A. So now you are now, which is in mole per dm cube. The pure concentration that you get here is in mole per dm cube. Now the pure concentration of A that you get here is in mole per dm cube. The pure concentration in mole per dm cube. That is the molar conc. So I told there are two concentration, mass conc and molar concentration. So the mass conc is this. The mass conc, this one is the mass conc of impure. This one is pure concentration, that is the molar conc of A. The molar conc of pure A. This can be tricky because they are giving us two concepts here, pure and impure. This is mass conc of impure. But what you get here is the molar conc. That's concentration in mole per dm of the pure. Why is this pure? That's the question that you need to ask yourself. Why did I call this one pure, even though we are using what? Impure salts? Because the one after the titration, the one that reacted with the acid, the amount of what? The quantity of A that reacted with B, which is the acid, it will be the salt that is in the solution. The sodium triisocarbonate 4 salt that's in the solution is the one that will react with the B. So that's why we know that the one that reacts is the pure. So meaning that the impurity will be left unreacted in the solution. So that's the mind behind this. The mind is that after you have dissolved it in the solution, after you have dissolved the impure salt in solution, then the pure salt that's in the solution will react with the acid. So by the virtue of that reaction, we can now get our pure concentration of sodium triisocarbonate 4 based on the reaction. So and that's what we calculate now. Now, they now say calculate the mass concentration of the pure concentration that you get. The molar conc is what we get, but we have to calculate the mass conc of the pure concentration. So to calculate the mass concentration now, you are going to use this formula that mass conc, which is concentration in gram per dm cube, is equal to the molar conc. The molar conc times molar mass. And don't forget, we are using pure now because the concentration that reacted here is the molar conc of the pure. So now, when I write mass concentration now this is just general formula, but what we are calculating now is the mass conc of the pure. So the mass conc of the pure now, I will just write the mass conc of the pure sodium triisocarbonate 4 will now be molar conc. This is the molar conc of the pure. So the molar conc of the pure is 0.0494 multiplied by the molar mass of sodium triisocarbonate 4. The molar mass. So I'm going to calculate the molar mass of this because the question says it's molar mass that we are going to use here. So the molar mass is, I'm going to manage this place and calculate the molar mass. We have sodium is 2 and sodium is 23. If you don't know how to calculate the molar mass of a compound, please follow me. Sodium here is 2, right? And the atomic mass is 23, so 2 times 23, that's how we do that one here. Plus, here we have carbon. Carbon is just 1, so 1 times 12 plus oxygen. Oxygen here is what? Oxygen here is 3, so 3 times 16. So that's how you get the, when you've add everything together, you should get 106. So 0.0494 times 106 gram per mole. Gram per mole. Usually, if you calculate it separately, you are going to get your molar mass in gram per mole. So I just want to clean this here. So the final answer here is 0.40 494 times 106. This is 5.2364. Okay, now gram per dm cube, you must be able to put your units very clearly. Gram per dm cube, gram per dm cube, gram per dm cube. So that's that about that. Now the last one has a percentage of the mass of sodium triisocarbonate 4 in impure sample. Percentage of mass. Percentage of mass. Let me just write it there. Percentage of mass of sodium triisocarbonate 4 in the impure now. Now, after you have gotten the mass conc of the impure, because this is the mass concentration of the pure now. After you have gotten the mass concentration of the pure, you now say what is the percentage This is just a mathematics question. You have gotten the pure of sodium triisocarbonate 4 and the impure is this 6. So what is the percentage of the pure in impure? So you are going to just put this all over this times 100. So this is the total pure. This is the pure plus impure, 6 grams. So put this all over this times 100. That's what you are asked to do when they say percentage by mass. So I will just clean this and then write percentage by mass. So percentage by mass of CO3 in, or percentage mass of what? Of pure CO of N2 CO3. You can write it wherever you want to write it, equal to 5.2364 over 6 times 100. So whatever you get is answer divided by 6 times 100. So we have about 87.27%. So that's that about the question on volumetric analysis. Please, if you enjoyed this video, please do it to like and subscribe. Thank you for watching. God bless you.